Okay, let's have a look at differentiating functions involving products and quotients. Before we do that though, from the introduction to implicit functions, you've had a go at a few now. There's a shortcut. We don't need to go through that whole process a lot of the time to work out what the implicit function is. We can almost write it down once we're used to it. If we think of this example here, differentiate this with respect to x, this function in terms of y, we know now that this equals the differential with respect to y of the function 3y squared, but then you multiply that by dy by dx, and that equals, what's the differential of that function with respect to y? 6y times dy by dx. And so we often don't bother to put this intermediate step in. We look at this differential. What's the differential of 3y squared with respect to x? That's going to equal the differential with respect to y, which is 6y, but then times by dy by dx. Dx, because that's the variable I want to differentiate with respect to, and dy, because that's the variable I have differentiated with respect to. 6y dy by dx. What about this one? Differentiate with respect to t the function 3 cos 2 theta. Write down the answer. What do you think it is? Pause. Now, what do? We differentiate the function. Cos becomes minus sine. The 2 comes out. So that's minus 6 sine 2 theta, but multiplied by the differential of theta with respect to t. Okay, with that shortcut in mind of how to get from an implicit differential to the solution, let's have a look at in differentiating products and quotients. So the best way to do this is to look at an example, for example, and in the textbook, let's look at the one that's in there, d by dx of x squared y. So now we've got to differentiating something which has got two variables associated with it, the x and the y. We just want to differentiate with respect to x. It's a product. So effectively, we let the first bit, the u, equal the x squared term, and the y equal the v term. And if you remember the product rule, the differential of y with respect to x equals u dv by dx plus v du by dx. And think of it in words, the differential of y with respect to x just equals the first part times the differential of the second plus the second part times the differential of the first. With that in mind, we can pretty well write down the answer. So what's the differential of this function with respect to x? It equals the first part times the differential of the second part plus the second part times the differential of the first part. And that equals, well, x squared. What's this one? We need to differentiate with respect to x, y, so differentiate in terms of y, which is just 1, and then multiply that by the differential of y with respect to x. So that's times 1 times dy by dx plus y, and what's the differential of x squared with respect to x? 2x. So finally we can write this equals x squared times dy by dx plus 2xy. So you can see what we've done here. We've used this shortcut idea to just do the differential of y with respect to x to actually just give dy by dx in that case. Here's another example that's taken from the textbook on page 444. Think of the example we've just done. Let the first part equal u and the second part equal v. We don't need to really write this down. Just think of it in terms of that. think about the product rule, which is the first bit times the differential of the second, plus the second bit times the differential of the first. Write down what you think this is, and then have a look and see the solution that I've got. So I think this equals the first part, which is 2x cubed, times the differential of the second with respect to x. So that's d by dx of y squared, plus the second part, which is y squared, times the differential of the first part, which is the differential of, in this case, 2x cubed. This equals, to do this part of in here, we need to differentiate y squared with respect to x, so differentiate with respect to y, and then multiply by dy by dx. That shortcut that we were talking about. So this equals 2x cubed times 2y times dy by dx plus y squared, and I can differentiate 2x cubed with respect to x. That's 2 3s are 6x squared. So tidying up and the algebra to get the solution in the text, or just to tidy up, is always involved. 2 times 2 is 4. Put the x term first before the y, alphabetical order, times dy by dx plus 6x squared y squared. If we now look at this, we can try and factorize as normal. 2 comes out, and so is x squared. So we can call that 2x squared. And then what are we left inside the bracket? 2xy dy dx plus 3y squared. And looking at again, I could say I could also have taken a y outside. So to fully factorize, this also equals 2x squared y into 2x dy by dx plus 3y. Okay, here's another example. Differentiate with respect to x, the function 3y over 2x. Well, this involves y and x, and it's a quotient, so we need to use the quotient rule, which is over to the side here. dy by dx equals v du dx minus u dv dx all over v squared. And if you remember what that is in words, it helps. Remember, we call the top term u and the bottom term v. So in words, this means the bottom term times the differential of the top minus the top times the differential of the bottom all over the bottom term squared. And that's exactly what we do when we do this differential. The algebra is often a bit more awkward in this case, tidying up at the end. So let's have a go at this. So this will equal v, or the bottom part, times the differential of the top part with respect to x, minus the top part times the differential of the bottom part, which is 2x, all over the bottom part, all squared. So looking at it, this equals 2x times, right, so we need to differentiate 3y with respect to y, which is just 3, and then multiply that by dy by dx, minus 3y. I can do the differential of 2x with respect to x, that's just 2, all over, and we must remember when we're squaring 2x that we square the 2 and the x to get 4x squared. Tidying up now, 3 times 2 is 6x dy by dx minus 6y all over 4x squared. And it's well worth factorizing here because we can then do a bit of cancelling top and bottom. So if I can take a 6 outside the bracket, this leaves x dy by dx minus y all over 4x squared, and 2's goes into 4 and 6 to leave 3 over 2 times x dy by dx minus y over 4x squared, over x squared rather, over x squared, which I can combine together as they've done in the book, or taken the 2x squared underneath and call that 3 over 2x squared, and then multiply that by the bracket x dy by dx minus y. That could be written either way. Remembering that a over b is equivalent to a times 1 over b, which is effectively what's done here, what's been used here. Okay, let's finish by just looking at, in detail at example at the top of page 445. I have to differentiate this with respect to with respect to y. So we want to find dz by dy. Well, if we look at it, we can see we've got two terms we're going to differentiate, and the second term involves a product, 3x times by the cos of 3y. So we're going to need to use the differential of a product, and the product rule in this part of it, and then differentiate this bit separately and add that on. So that's what we're going to do. So writing it out, dz by dy actually equals d by dy of this bit plus d by dy of this bit. That's effectively what we're doing. We're finding the differential with respect to y. And so what we do is we do it in parts. Well, this part, we've got to differentiate with respect to x, so we must differentiate x squared with respect to x, which gives us 2x, then times that by the x dy. So this gives us 2x times dx by dy plus, now this one involves using the product rule, the first part multiplied by the differential of the second plus the second part multiplied by the differential of the first. So this is going to be the first part times the differential of the second with respect to y plus the second part times the differential of the first part. And this equals 2x dx dy plus 3x. Differentiate that with respect to y we can do. Difference of cos is minus sine, so it's minus 3 sine 3y plus cos 3y times the differential of 3x with respect to y. So we have to differentiate with respect to x, which just gives us 3, and then differentiate that by dx by dy. Now we just tidy up. 3 times 3 is minus 3 is minus 9 x sine 3y plus 3 cos 3y times dx by dy. Okay, now you can have a go at the exercise 177, page 445.